area of steel will be equal to, since there are 60 wires each of 2 mm diameter, so pi by 4 into 2 square, that will be equal to 188.4 mm square. Initial average stress in concrete will be equal to P by A. P is 300 into 10 power 3 to convert into Newton, by cross section area is 250 mm square, so 250 by 250, which is equal to 4.8 Newton per mm square. Modular ratio alpha will be equal to ES by EC, which is equal to ES is 210 kilonewton per mm square by EC is 32 kilonewton per mm square, so that is 6.58. Initial stress in steel wires will be equal to P by area of steel. P is 300 into 10 power 3 to convert into Newton, by area of steel is 188.4, so that will be equal to 1590 Newton per mm square. Losses of stress. First is due to elastic deformation. That is equal to alpha into Fc. Alpha is 6.58 into Fc is 4.8 Newton per mm square. So this will be equal to 31.5 Newton per mm square. Second is due to creep of concrete. That will be equal to shortening due to creep coefficient, that is creep coefficient. Shortening due to creep epsilon cc is given as 30 into 10 power minus 6 into Fc into Young's modulus of steel. Fc is 4.8 into Young's modulus of steel is 210 into 10 power 3 to convert into Newton per mm square. So that will be equal to 30 Newton per mm square. Third loss is shrinkage of concrete. Which is equal to shrinkage coefficient epsilon Cs into Young's modulus of steel, that is equal to 200 into 10 power minus 3 into Young's modulus of steel is 210 into 10 power 3 to convert into Newton per mm square. That will be equal to 42 Newton per mm square. Whereas stress due to relaxation of steel, which is equal to 5% of the initial stress, 5% of 1590, that is equal to 5 by 100 into 1590, which is 79.5 Newton per mm square. So the total loss is 183 Newton per mm square. Then now effective pre-stressing will be, effective pre-stress is initial minus loss, that is 1590 minus loss is 183, which is 1407 Newton per mm square. Final stress in concrete will be force by area. Force is effective pre-stressing force in the steel is given, so is obtained into cross section area of steel, that is 188.4, will give us the force, by cross section area of concrete is 250 by 250, that will be equal to 4.26 Newton per mm square, and the percentage loss will be equal to loss by initial, that is 183 by initial is 1590 into 100, which will be equal to 11.6%.